So it's most of the time I'm not going to tell you what you need to use, right? And you're going to have to figure out what you need to use. Is it trigonometric ratios, or is it sine law, or is it cosine law? How can I figure out which one to use, right? So all the time, what you want, if you're not given a picture, you want to draw a picture, okay? And you always have to remember that if you're talking about a wall or a cliff or something that's on the ground, that thing is perpendicular to the ground. The word perpendicular means they form a 90 degree, okay? So if you have, let's say, a wall and a ground and a ladder, right? The wall and the ground, they form a 90 degree, a perpendicular, okay? So in this situation, when I have a perpendicular or 90 degree triangle, what can I use? With right angle triangle? SOHCAHTOA. That's right. You can use SOHCAHTOA, right? If you have a right angle triangle. And then in the other scenarios, you just use sine line, cosine line when you don't have a right angle triangle. Now also remember that with right angle triangle, there's also the Pythagorean theorem, right? Because sometimes you need to know the Pythagorean theorem, you need to solve for the third side, and you need to use the Pythagorean theorem. Do you guys remember what the Pythagorean theorem is? A squared, yeah, plus b squared equals c squared, right? And then the c is the hypotenuse, right? Okay, so first of all, step to solving trigonometric problems, you're going to state the given, and right? So state the given and draw a diagram. Then you're going to choose the appropriate formula. So for right triangle, you're going to use the trig ratios, which is SOHCAHTOA. Or you can use, we said, the Pythagorean theorem, right? Which is a squared plus b squared equals c squared. And remember that c represents the hypotenuse. Otherwise, you're going to have to change your formula a little bit. In a non-right angle triangle, I can use either the sine law or the cosine law. If I have one pair of opposite side and angle, what can I use? Opposite side and angle.
So the sides.
Sine law. Right? Sine law can only be used if I have an opposite side and an angle. Okay? And the sine law would be either like sine A over A equals sine B over B equals sine C over C. Or I can use the other formula, which is A over sine A equal to B over sine B equal to C over sine C. Right? So I can choose whichever formula I need. If I'm finding the side, I'm going to use the second formula. If I'm finding an angle, I'm going to use the top formula. And then if you have a scenario where you have, let's say, two angles, and let's say this side, they gave you side A, for example, and they gave you angle B and C, right? You can always solve for angle A first, right? Because you need the two opposite information, right? So you have to solve for angle A. You know two angles. You're looking for the third. It's just 180 minus the other two, right? You remember that? Because the sum of all the angles inside of triangle is 180, okay? So this is what it says here. The third side can be found from subtracting the third angle can be found from subtracting two angles from 180, okay? So in case you need that angle to solve. Okay, fix that please. It's the third angle, not the third side. And then if you're given two sides and a contained angle, or if you're given three sides, what formula do you use? The cosine. And the cosine law, you have two different formulas, either the a squared equal b squared plus c squared minus 2bc cos a, and that's in the case of the two sides and contained angle, or cos a is equal to b squared plus c squared minus a squared over 2bc. You can use either one of these. Okay? Are we okay with this? All right. So this is kind of like a map of, is the triangle a right triangle? Yes, then if it is, then you use the primary trig ratio, which is SOHCAHTOA or Pythagorean theorem, right? If it's no, then are you given two angles and an opposite side? If yes, then you use a sine law. If no, are you given two sides and a contained angle, or three sides, then use a cosine law. So this is pretty much a map. Once you decide which you're gonna use, you're gonna solve for the missing variable. Make sure the answer fits or in the context of the question, and write a final statement. All right. From the top of the Niagara Escarpment, hold the car below at an angle of depression of 40 degrees. He's approximately 100 meters above the car. How far is the car from the base of the escarpment? Round your answer to the nearest meter. So what do I have here? Right angle? Yeah, it's a building. It's something that's built, right? So that means it's gonna have to be right angle to the ground, hopefully, right? Right? So I have a right angle here. Juan is right here at the top, and he sees the car at the bottom. Where is the angle of depression of 40 degrees? Right here? What do we know about angle of depression? It's measured from what? Measured from what? It's measured from a horizontal line, right? So Juan is looking, that's his eye of sight, and he is looking down. Where's the angle of depression?
It's down in the car.
It is going to be down there, right? But technically it's up here, right? Now, eyes on me for a second. There's two ways that you can do this. if you remember the Z rule, I don't know who remembers that, but I showed you this yesterday, or some of you saw this yesterday. So you have the alternate angles. If you look at the alternate angles, so when you have two parallel lines, which is I have the horizontal lines here, and then you have a line between them, right? This angle and this angle, we call them the alternate angles, and they're equal angles, okay? So that means if I'm looking here, then this is 40 right here. That's one way, if you remember that. Or if you don't remember that, this is 40,
19.
right? Because this is a horizontal line right here, and this is a vertical line, so that means this is gonna make a 90 degree. And if this is 40, that means this is 50. So there's two different ways that you can come to this. You either remember that you have the alternate angles, and they're equal to each other, or you remember that this is going to be 90 between the horizontal and the vertical, and if this is 40, that means you're left with 50 up there. Doesn't matter which one you follow, it's gonna be the same. Are we okay with that? All right. You can never use the angle outside the triangle. So this angle here, I can't use. Okay? I just can't use it to find the other angle. I can't use it in my measure, and I can't use it in my calculation. Now, Juan is approximately 100 meter above the car. So where's the 100 meter? So he's 100 meter above. And then what are we trying to find?
The C, the height. The base.
Yes, because how far is the car from the base of the escarpment? Right? How far is the car from the base? So that means I'm looking for this side. Okay? According to this triangle and to the angle of interest, name the triangle for me. Name the opposite adjacent hypotenuse. The 100 is the opposite because that's opposite from the angle of interest. Okay? That's the adjacent, correct. Good. Now, I'm looking for the height, I'm looking for the adjacent, knowing the opposite.
Sorry, can you repeat the question?
I know the opposite, looking for the adjacent.
So you can use the angle of 50 with the down.
No, I named my triangle according to the angle 40. Right? Because if you use the angle 50, then your name of the triangle is going to be different. You're going to end up with the same answer, but it's going to be different. Naming. Right? So let's stick with the 40 as my angle of interest. What do I use? I know the O, I'm looking for the A.
So tangent. Tangent.
Tangent. So tan 40 is equal to 100 over the adjacent. How do I find the adjacent?
Switch the place of
Yeah.
adjacent and the tangent for it.
That's right. So A is going to equal to 100
Over tangent
divided by tan 4.
is 119.1.
So what did we get?
119.2.
Because they want the nearest meter, so this is where I said unless otherwise specified in that question, right? So in this case, it's otherwise specified that they want it to the nearest meter. So in this case, my answer is going to be the car is 119 meter from the base of this car. Yeah.
So first I left out since this I
You can,
Okay,
that's okay. So what you were saying is that you formed your triangle like this,
yes,
right?
and the angle there is 40.
And this is angle 40,
Yeah.
and then this is 100,
Yeah,
right? This is still your opposite,
yeah.
and you're still looking for this.
So I got confused because you said you cannot use that 40 on top. Why?
Well, because that 40 on top was outside my actual triangle that I drew.
Oh, when you form the.
Yeah, but when you
that
form
way.
it the other way, then it is inside, yeah?
Ah,
Are we okay with this? All right. Ready for the next question? Micah is standing on the ground between two buildings on the opposite sides of a park. So Micah is standing in the middle on the ground between two buildings. So Micah is here, and the two buildings are on either sides of him or her. The top of the first building is 152 meters from Micah. At an angle of elevation of 38. While the top of the second building is 175 meters from Micah at an angle of elevation of 53. How far apart are the top of the two buildings? And round your answer to the nearest meter. So what do you draw here? Okay, so that's Micah right here. Where is it? One second. Okay, so that's Micah right here. Two buildings. Okay. All right. They should be at the same ground level as Micah, I think. Maybe this is a little bit longer right here. Okay.
And then the angle of elevation for the first one, about 50, oh, the smaller one, right?
So the smaller one I have
Looking up at it, so it's, that's 152.
152. Okay, because that's the top of the building, right?
And then
All right.
the angle, which is 38.
Which angle?
The angle of elevation
Which means?
when he's looking up.
So that means it's this one?
That one.
Okay.
And then you have the second one over on that side,
Okay.
which is 175 meters.
Okay.
And then, just,
All right. Then I'm looking for
you're looking for the base.
how far apart are the two buildings, the top of the two buildings. Okay? I'm looking for the top of the two buildings, not the base,
Sorry, on the base.
because this is not a rectangle. You have to be careful here. Because the buildings are not the same height. Right? They're not the same height. So I'm looking at the top of the buildings. All right. Do I have the angle?
Yeah, because you have 38 and you have 53.
Yeah.
And then you minus that from 180.
So what Bright's saying is that my pocket. Saying that I can find this angle right here, right? And I can find this angle because my whole angle for this is 180, right? I know 53 and 38, so I can find that middle angle, right? Because 180 minus 38 minus 53, what do I get? 89. And that's going to be this angle right here. Now, if you look here, you have this big triangle. What kind of triangle is this? Oblique. And then I know two sides and what angle? The contained angle. And I'm looking for this side. I'm just going to name them A, B, C. So I'm looking for side B. I know side C. I know side A. So what would be my formula? B squared equals A squared plus C squared minus 2AC cos B. So B squared equals 152 squared plus 175 squared. Doesn't matter which order you put them in. Do you have an answer for me?
Can you use a different number, different idea?
What do you want to do?
To do cosinus with both triangles and add it together.
No, because the bottom, this bottom, does not have to equal the top. It's not at a rectangle.
Oh,
Okay? What did we get for B squared? 800? 52,000? Okay. Okay, and then you did the square root? 230?
If you went from there.
To the nearest meter, right?
Yeah, so it's 229.7.
Okay, so it's 230. So therefore, the top of the two buildings are 230 meter apart from each other. Don't forget your therefore statement. All right, so here's what I want you to do. I want you to try the next question.